welcome back. And the time has finally come to talk about arrays. So what will we learn about arrays in this chapter? We will learn about the basic features of arrays, the difference between fixed size and dynamic sized arrays in Solidity, and what happens when we store arrays in different data locations inside Solidity. So arrays are just collection of elements. If you have any experience in coding in another language, you already know what arrays are. I will not spend much time explaining what it is. However, there are some Solidity specific rules about arrays, which is worth taking a look in details. So here's some Solidity specific things that you might want to know. It can have only one type of elements. For example, if you declare the array as unsigned integer, then all the elements of this array has to be unsigned integers. You cannot mix and match unsigned integer and strings like say what you can do in JavaScript. The second thing to note is arrays can be stored in different memory locations or different data locations in Solidity, and those data locations are memory, storage, or call data. And depending on where they are stored, they act differently. I will go through the details of these three data location arrays in details. And last but not the least, arrays can be of fixed size or of dynamic size. What do I mean by that? I mean that you can initiate an array by saying unsigned integer 5 my array. This means that the size of the array will always be 5 and it can only hold 5 unsigned integers. You can also initiate an array by saying unsigned integer without any size, and then it would be a dynamic array. There are many reasons why you would use one over the other. Mostly though, you would like to use a dynamic array, and then you can use fixed size arrays to be more gas efficient. Remember that I told you that you can actually have arrays in different data locations. One of those data locations is storage. Most of us, when we think arrays, we actually think of storage arrays, as it is the most what we see in other languages. They act and behave like storage arrays. So let's see how storage arrays behave. So before we do that, let's ask the question, what exactly a storage array is? Storage arrays are basically arrays that are in state variable, or the arrays inside the functions which we explicitly declare them as storage, like this: unsigned integer, storage, numbers. So this numbers array is actually a storage array inside the function. And what are the characteristics? The characteristics of the storage array are like they can be either fixed or dynamic. We can choose whatever you want to do, and they're always stored permanently where the state variables are stored. And they also have members like push, pop, and length. By that I mean you can just say, let's say numbers is a storage array like we declared here. So you can say numbers dot push 5, and 5, the element 5 gets pushed in the numbers. And then you can use pop to pop the last element of the array, and then you can just use length to get the length of the array. Cool. Now let's move to live coding, where I will show you how you can work with storage arrays. For that, we go back to Remix. I'm going to delete this entire thing and change it to storage array example. So what will we do in this contract? In this contract, I'll show you how to create an array, how to create a storage array, how to read from a storage array, how to update, and how to delete elements from the storage array. The basic create, delete, read, and update thing that we have been doing for other data structures. Let's start by defining a storage array. We'll make it public so we can actually see the state whenever we want to. Then we use numbers. Then I'll show you how to add elements to the array. Add elements to the array. And we will do inside a constructor. So this will run whenever the contract is getting deployed, and it will only run once. So let's do numbers to push 5. Let's do a couple more. Cool. So now that we have added elements to the array, we can actually try and update them. So let's say we want to update the last element in the array. So what should we do? So we will write a function update array, and this should be an externally called function, because we'll call this from outside, and it doesn't really need to return anything. So what will we update? We can pass in the index of the element we want to update, and what we should update it with. So for that, it will need two input parameters. So it could be uint index, and the other thing could be the uint updated value. So you pass an index and updated value. We will go find that value from this array and update it with updated value. So for that, all we need to do is pull out the index value from here like so, and replace that with updated value. That's all we need to do. Cool. Now let's say we want to delete an element from an array. Delete. What should we do? Oh, well, if you guessed the keyword delete, you would be right again. Now let's see how we can use it in arrays. Function delete array. It should again take an unsigned integer index, and it does not really need to return anything. So, but it will be called from outside. So it would be the external. Oh, I'm just saying externally. It should be external. Sorry about that. Then the keyword delete. All you need is numbers, index you want to delete. Right. So let's see if that works. If we can compile this. Up, this compiled without any problems. Let's clear this. Then let's try and deploy it. And that's the only contract we have here. That's JavaScript VM. The account is set and deploy. Awesome. So we have these numbers and all these elements got added whenever the contract got deployed. The zero index should be 5, one index should be 6, and second index should be 9. So let's try and see if that works. 2 is 9, 0 is 5, and 1 is 6. Awesome. Now let's see if we can actually update this array. Let's say we want to update the index 1 with number 12. Call it like so. We pass in 1 for index and 12 for updated value, and then we hit this. Transaction went through. Now let's see what the index 1 of numbers is. It is 12. This worked. Now we can try and delete it. Boy, we really don't like the index 1, do we? So we just delete this. And now let's see what happens. And it defaulted to 0. So that worked. What if we want to see a number that's not in this? So let's pass in 5 and see what happens. As you can see, there's an error. All right, now I kind of want to show you how to loop through an array. I also want to show you this because I want to show you how to use for loops inside contracts. This is a cool thing. If you don't know this already, if you are coming from another programming language, this should be pretty straightforward and simple. So let's do add numbers. What I want to do in this function is pass in a number to this function, add that number to each element of the array. Let's see how that works. So let's say pass a number function that each element. Cool. So for this, we have to loop through the array and add it to each elements. This should have input parameter of unsigned integer, and we can just call it number. And this should be called from outside, so it could be external or public. I'll just go with external. It doesn't really have to return anything, and that's that. Now let's do the for loop. So the way for works is for unsigned integer I equals 0, I less than I plus plus. So you go through the entire length of the array, and then you take this I keeps increasing in each loop. So you take them out like this, numbers I, and then you add this numbers that you passed in, and that should be it. Well, let's see if we can compile this again, or it will throw any errors. There was an error. Right, I should have just passed in number and that not numbers, because underscore number is the parameter. And there is another error. Okay, so that should be small letter I and not capital I. I'm sorry. Try and compile this again. There should not be any errors. We got the ABI and the bytecode, and here's the deployment. So we can close the older deployment and try and deploy this again. So we got a new instance of deployment, and we have a new function here called add numbers. So if we look at the numbers again, because it got deployed again, it will have 5, 6, 9 again as the new values, regardless of what we did in the last storage, because that was a different contract. So 1 is 6, 2 is 9, 0 is 5. So let's add 5 to all the elements. In that case, 0 should be 10. 1 should be 11, and 2 should be 14. Oh, there we are. It works. So that's it for storage arrays. Now let's go back to our slides. So yeah, so I've shown you what storage arrays are, and as I mentioned before, the storage arrays that we used here was actually dynamic arrays, but I could have easily done 3 here, and that would have made the storage array a fixed array, and it would have still worked properly. Although, well, if we do the fixed array, then we cannot use members like .push or .pop. So this would not have worked. I would have had to just say 1, 2, 3 here, and or 5, 6, 9 here, my bad, and it would have worked like that. And also .length doesn't really make sense for a storage array because you know what the length is when you initiate it. So yeah, so now let's move on to arrays. that are stored in memory. So what are memory arrays exactly? They are definitely not state variables because they are stored in a different data location, and they are normally found inside functions or function parameters. Like here, my function, this numbers, that can actually be a memory. We just have to make sure that this function is actually an internal function, and the reason for that I would explain later. But remember that for memory arrays in the function parameters, the function has to be internal. We can also have memory arrays inside the function itself as long as we use the keyword memory. Memory x equals numbers. So these are the two places where you'd find memory arrays. And what are the characteristics of this? Unlike the storage arrays, which can be dynamically sized, memory arrays will never be dynamically sized. You cannot resize a memory array. Push pop will not work, and length is just doesn't really mean anything because you already know this length. It also cannot be stored permanently inside a state variable. So this is not the right data location for variables. Cool. So now the question you might ask is, why would you ever use it, right? The storage arrays are so much better. The answer to that question is that Solidity is not exactly like other languages. It does work in a space constrained and computationally constrained workspace. So you want to squeeze out every juice of optimization as possible. So that's where memory arrays come into place, and it takes less cache for using memory arrays. And you always want to write memory efficient or cache efficient code. So that's where you will use memory arrays. There is also a third place where you can store your arrays, and that is called call data. It is almost like memory arrays, and it is not stored permanently. Like memory arrays, once the function gets executed, call data is gone because it's in the stack memory location or stack data location. And they're normally used in the parameters of externally called function, like how we have memory in the parameters of internally called functions. The external functions will have their parameters stored in call data. And there is a reason why we do this. And as again, I'll go through that when I go over call data and memory and other data locations types. Yeah, that's what I just said. We'll go in details of storage, memory, and call data in later chapters. Just for now, remember, if you use external, be sure to use call data. If you use internal, then you can use memory. I mean, no one will stop you from using call data here, but you should definitely use memory here to call data in external. Another thing of note is that variables of type bytes and string are actually special arrays. The bytes type is actually array of byte, but the only difference is they're tightly packed. What that means is uses memory efficiently, and they use the least memory space possible, and they are stored in call data and memory data locations. String is exactly like the array of bytes, but it does not have the extra members like length, and it doesn't have string access. So you cannot call string 0. So you cannot have string, my string equals, who goes there? For reason H should be capital, and you cannot do my string 0 or 1. This is error. Cool. So that is all I have to say about arrays, and I'll see you in the next chapter.